Cleanroom Class 1000 electrical system design involves several important design considerations. Power quality is key, so ensure stable and reliable power for sensitive equipment. Consider using uninterruptible power supply systems, surge protectors, and line conditioners. Circuit segmentation is another important aspect. Separate critical and non-critical circuits to minimize the impact of outages. Grounding is very important. Establish a low-resistance grounding system to prevent electrostatic discharge and interference. For lighting, use filtered lighting fixtures to minimize particle contamination. When it comes to outlets and wiring, select outlets and wiring materials that minimize particle generation. Consider using shielded or filtered outlets. Control systems are relevant too. Integrate automated controls for lighting, heating, ventilation, and air conditioning, and monitoring to minimize human intervention. Requirements include adherence to several standards. Firstly, NFPA 30 is the National Fire Protection Association standard for the Flammable and Combustible Liquids Code. It requires proper wiring and equipment selection to prevent ignition sources. Secondly, IEC 61184.1 is the international standard for the design and testing of cleanrooms. It specifies electrical safety requirements, including grounding, surge protection, and equipment testing. Thirdly, ISO 14644.1 is the international standard for the classification of cleanrooms. It defines Class 1000 as having a maximum number of particles 0.5 microns and larger per cubic foot of air. Specific electrical requirements need attention. Grounding is critical. The resistance of grounding system should be less than 1 ohm. Isolation transformers are relevant. Use isolation transformers to isolate critical circuits from the main power system. Shielding is also important. Use shields around motors, transformers, and other electrical devices to minimize electromagnetic interference. Laminar flow filtration is necessary. Ensure airflow prevents particle accumulation on electrical components. HEPA filters are vital. Use high-efficiency particulate air filters to remove particles from the air, including dust and oils that can contaminate electrical equipment. Additional considerations include documentation. Keep thorough documentation of the electrical system design, including drawings, specifications, and test reports. Maintenance is also crucial. Establish a regular maintenance schedule to ensure the electrical system remains compliant and functional. Training is necessary. Train personnel on proper use and maintenance of electrical equipment in the cleanroom.